So here is the part 3, a continuation of the Scholastic Aptitude Test preparatory examination questions. So today, based on the curriculum of Scholastic Aptitude Test, we want to look at the topic circuit elements and DC circuits. So let us look at the following practice questions. Questions 1 to 3 refers to the circuit diagram below. So we have two resistors that are connected in parallel to a 4 volts DC voltage. So question 1 says, what current will flow through the 4 ohms resistor when the switch is closed? So when the switch is closed, we have a closed circuit, and in a closed circuit, current will definitely flow through. So the keyword there is current will flow through the 4 ohms resistor. Don't forget that voltage remains the same in a parallel arrangement. So therefore, for parallel resistors, they will receive the same voltage. So total voltage equals to voltage across each of the resistors, which will be 4 volts. So using Ohm's law, V equals to IR, then I equals to V over R. So I equals to 4 divided by 4, which gives us 1 ampere, which is option B. Question 2. What is the total equivalent resistance of the circuit when the switch is closed? So the keyword there is total equivalent resistance of the circuit. So this is still a parallel arrangement of resistors. So total resistance is obtained by multiplying the two resistors divided by their sum. So simply say 4 multiplied by 2 divided by 4 plus 2. And that gives us a total resistance of 4 divided by 3 ohms, which is option C. Question 3. What is the total power dissipated in the circuit when the switch is closed? So the keyword there is total power dissipated in the circuit. So there are 3 possible equations that we can use. We can say P equals to IV, where P is the power, I is the current, and V is the potential difference or the voltage. We can also say P equals to V squared over R, where R is the resistance. We can also say P equals to I squared over R. For simplicity, let's use P equals to V squared over R, which is 4 squared divided by 4 over 3, which gives us 12 watts, option D. Questions 4 to 8 refers to the following circuit diagram. We have 2 resistors in parallel and connected in series with another 4 ohm resistors, all together connected to a 10 volts DC power supply. Question 4 says, what current will flow through the 4 ohms resistor? The keyword there is current will flow through the 4 ohms resistor. So these are under parallel arrangements. So we sum up the parallel arrangements by saying 2 multiplied by 2 divided by 2 plus 2. That gives us 1 ohm resistance in parallel. Then we add it up to the 4 ohms resistor that is in series with the other 2. So that gives us 1 plus 4, which is 5 ohms. So applying Ohm's law and making I sum the formula, we have I equals to V over R, which is I equals to 10 over 5, which gives us 2 amperes. So the 4 ohms resistor is in series, and the same 2 ampere current passes through it, which is option C. Question 5. What is the voltage drop across the 4 ohms resistor? The keyword there is voltage drop around the 4 ohms resistor. So we just simply use Ohm's law, V equals to IR, where our I is 2 amperes, R is 4 ohms. Multiplied together, we have 8 volts as the voltage drop, which is option D. So question 6, how much heat is generated in the 4 ohms resistor in 2 seconds? So the keyword there is heat is generated, and then we have 2 seconds. So we simply apply Joule's law here, and Joule's law says the quantity of heat energy equals to I squared RT, Q equals to I squared RT. So I is 2 ampere, you square it, R is 4 ohms, then T is 2 seconds. When you multiply the 3 together, you have 32 joules as the heat generated in 2 seconds. which is option E. Question 7. How much power is dissipated in the 4 ohms resistor each second? So the keyword there is power is dissipated in each second. So we apply the power law, the power equation, P equals to I squared R. So don't forget that power is the rate of energy use. In other words, power is joules per second. So power equals to I squared R, which gives us 2 squared multiplied by 4, which is 16 watts. Option C. For question 8, what is the voltage drop across the 2 ohms resistor labeled R1? So the keyword there is voltage drop and R1. So voltage adds up in series arrangement. So the total voltage will be V1 plus V2. Then voltage is the same in parallel arrangement, such that voltage across the parallel arrangement equals to voltage across each of the circuit elements. Now, the battery has a voltage of 10 volts, and the 4 ohms resistor is in series with the battery, and with resistors 1 and resistor 2 combined. Now, in question 5, the voltage of the 4 ohms resistor was found to be 8 volts. So we can simply say the total voltage equals to voltage across resistor 1 and 2 plus voltage across resistor 3, which is 10 equals to V across 1 and 2 plus 8. So making V across 1 and 2 subject to formula, I'll have V across 1 and 2 to be 2 volts, meaning that resistors 1 and 2 are in parallel, and the voltage across each of the parallel arrangements is 2 volts, which is option A. Questions 9 to 10. The circuits shown below are connected to power sources that provide the same electric potential V. Question 9. Which of the circuits will dissipate the most power? So don't forget the keyword there, dissipates the most power. So applying P equals to I squared R, the more resistors in parallel, then the lower the overall resistance will be. And then the lower overall resistance will lead to more current flow. So option B is the correct answer there. Last question. Which of the circuits will have the same voltage V across each one of its resistors? We have the keyword same voltage V. We have same voltage V, then across each one of its resistors. So we apply voltage across parallel arrangements, which is Vp equals to V1 equals to V2, the same voltage flows. So resistors in parallel receive the same voltage. So option D is the correct option there. Thank you all. God bless you.